6.6 Geometric sequences. So a sequence is an ordered set of numbers. So here's a sequence. It's just a list of numbers. It can be any list of numbers. Okay. So this we often use a sub n to indicate a sequence, and this would be a sub 1. It just means it's the first term in sequence A. So the term number is 1, the term value is 2. Okay, so this one, for example, the 8, the term value is 8, and this would be the 1, 2, 3, 4th term in that sequence, so that would be a sub 4. Okay. All right, an arithmetic sequence, we've talked about these before, has a common difference. And that means you're going to add the same thing to get from term to term. So this happens to be an arithmetic sequence because we're adding 2. 2 plus 2 is 4, 4 plus 2 is 6, and so forth, right? So this is what you add by to get from one term to the next. You could also think of it as subtraction. If you're subtracting the same thing to get from term to term, then you're really adding a negative. So that works either way, okay? But sometimes it's not going to work adding or subtracting. So if you look down at these sequences, we can't add to get to the same from one term to the next here. 4 plus 8 would be 12, and then it's going to be 24 to get to the next term. So we're not adding. It doesn't work with adding on either of these, or subtracting here either. Okay, and that's because these are going to be geometric sequences. A geometric sequence has a common ratio. And that's what you're going to multiply by to get from term to term. So if you're multiplying by the same thing every time, then you've got a common ratio and you've got a geometric sequence. Okay. So let's look for a pattern here. I'm thinking 4 times something equals 12. Well, that would be 3. And 12 times something is 36. 36 times something is 108. And those are all going to be 3. So that means my common ratio here is 3. Okay. Now let's say, if you wanted to figure out what the ratio between 36 and 108 is, and actually the ratio anywhere along the line, you can always take a term value and divide by the previous term. So you can't do that with the first one. First, there's no previous term, but I can do 108 divided by 36 if I didn't already know it was 3, and I can see it's 3, right? And you could do that with any of those and check your ratios in that way, okay? And then we can find the next 3 terms just by using the ratio. So I'm going to do, okay, I'll do 108, whoops, I did 180, 108 times 3 is going to be 324. So the next term would be 324. Okay, and then I'll multiply by 3 again to get to the next one after that. 972, and then I'll multiply by 3 one more time, and I've got 2,916. Okay, and there's my next 3 terms. Okay, all right, let's try another. So looking at these are getting smaller as we go from left to right. So it might seem, hey, I'm not really multiplying, I'm actually dividing because the numbers are getting smaller. So that's true. You can think of this as division. Okay? So you could think, okay, it's with 100 divided by something is 20. That would be dividing by 5, right? 20 divided by 4, 5 is 4. And let's check it out. 4 divided by 5 is going to be 0.8. 0.8. Yes, we are dividing by 5. But that's not the common ratio, because the common ratio, you want to think of it as multiplication. Okay? But the good news is if you're dividing by 5, that's the same as multiplying by 1/5. Because then you'd be taking a fifth of each term to get to the next term. Taking a fifth is the same as dividing by 5, right? So we can try it here. 1/5 is the same as 0.2, right? 1 divided by 5 is 0.2. So I can try it out. 100 times 0.2. Well, that would give me 20, and then I can multiply by 0.2 again, and it works all the way down the line. Okay, and I can test it out. So my ratio, I could say, is 1/5, or if as a decimal, 0.2. Either way is fine. Okay, and then the next 3 terms. So I'm starting at the 0.8, which I already have on my calculator, and multiplying by 0.2 again. So I'm going to do this as a decimal, but you could also do a fraction. So I've got 0.16, and then I'll multiply by 0.2. And one more round of multiplication. And I've got 0.0064. There's my next three terms. Okay, on the next page, we're going to look at graphing a geometric sequence. So we're going to graph this using the term number as the input and the term value as the output. So we've got 2, 4, 6, 8, or sorry, 2, 4, 8, 16, 32. And you can see those are the term values. So those are my outputs, right? My term values are the outputs. And then I got the term numbers as the input. So, you know, this would be a sub 1, this is a sub 2, and so forth. So I've got my first, second, third, fourth, and fifth term here, okay? So let's see, for term 1, the value is 2, so I'm going to plot the point 1, 2 right here. Okay, then I'm going to plot 2, 4, 3, 8, 4, 16, and 5, 32 is going to be in the top right corner there, okay? And it's a little bit hard to see here, but hopefully you can see a pattern that's developing here, okay? So when you graph a geometric sequence, it's going to fit on an exponential curve. Okay, so by that I mean if we drew a curve, something like that, and this is what an exponential curve would look like, right? So all those points are going to fit on an exponential curve, okay? So that's for a geometric sequence. If we were to graph an arithmetic sequence, which we already did in a previous section, that's going to fit on a straight line. Okay, so that's nice because you can, if you know that pattern, because if you're looking at a graph like this, you can tell pretty quickly if it's going to be, if it looks like it's a geometric sequence or an arithmetic sequence based on whether it's an exponential curve or a straight line. Okay. All right. That brings us to the what I call the geometric specific term formula. And that means when I can use this formula when I've got a geometric sequence and I want to find a particular term. Okay, so this is asking me, this example is asking me for the 72nd term. So, you know, I could find the ratio and build out the sequence all the way to the 72nd term, but that would be a pain. That would take a while, right? And it's a lot of, even if you're using a calculator, there's a lot of chance you'll lose your place and make a little mistake. So it's easier on problems like this to use this formula, okay? So a sub 1 is going to be the first term. Okay? The r is the ratio. And then the n is going to be the term number that you're looking for. Okay? So let's try out this formula then. So we're looking for the 72nd term. So I'm going to write a sub 72. All right. And then my first term is 3. I can see that that's 3 there. The ratio I need to figure out. I should have left myself a little space. But I'm thinking, what am I multiplying by to get from term to term? So it looks like 5, right? We're multiplying by 5 to get from 3 to 15. And let's just double check. 15 times 5 does equal 75. So then I know my ratio is 5. Sorry, that's written so small, but the ratio is 5. And then, so that's going to go there. Okay, and then I've got n minus 1 as an exponent. And the n is the term number that we're looking for. So here, that's 72. Okay. So now I need to simplify this. So first thing I'm going to do is simplify the exponent. This is going to be 3 times 5 to the 71st. All right, and now it's a really easy mistake to make. I'll see a lot of people say, oh, this is 15 to the 71st, but it's not. It's not 15 to the 71st. We've got to follow PEMDAS, which means we're doing the exponent next. Okay, so this is going to be a pretty large number because we're raising 5 to the 71st. Okay, and so I've got this, it looks, hey, that's not that big, 4.23, but wait a second, it's got this E49 thing at the end. So if you see that on your calculator, that means we're dealing with scientific notation. So it really means it's this decimal times 10 to the 49. So in other words, that the decimal point is going to be to the right 49 spaces. So it's a very long, number, a very large number. But that's okay. I'm just going to write it in scientific notation. So I'm going to take this number from my calculator, and the last thing I'll do is multiply that by 3. Okay, and then I'm going to say about, because I can't write out the whole number, but I've got about 1.27, and I want to write times 10 to the 50th. And it seems like, how could it possibly get so big? But if you multiply by 5, it gets really big quickly. So let's just do a little test. Okay, there's my first 3 terms. But you can see it's growing quickly because it's really growing exponentially, right? So those numbers are getting big very quickly. And you can imagine if I went 72 numbers down the line, it'd be a very big number. Okay. All right, let's try another. We're going to find the 15th term. These are getting smaller, so I'm guessing the 15th term is going to be a very small number. So let's find the ratio. Looks like we're dividing by 5, which we are, but when we're thinking of that as multiplication, we're going to be multiplying by 1/5. So we're taking 1/5 of each number to get to the next number. So our ratio is 1/5. And just to make it easier to put into a calculator, I'm going to put the decimal form of that, which is 0.2, right? 0.2. You can see that 1 divided by 5 is 0.2. All right, so let's try the formula. I'm looking for the 15th term here. The first term is 5. Then the ratio is 1/5. And then we've got n minus 1. N here is 15. Okay, so this is... And I said I was going to put this as a decimal, so let me change this to a decimal. Okay, got that, and I want to do the exponent before the multiplication. Okay. So yeah, some people look at this and say, oh, 1/5 of 5 is 1, so this is going to be 1 to the 14th. Well, 1 to the 14th would just be 1, which is definitely not going to be the 15th term here, okay? Because that, if you did that, you aren't using PEMDAS. All right, 0.2 to the 14th. It's a very small number. Got scientific notation again. This means the decimal is going to be moved 10 spots to the left from here. So it's going to be a decimal point, 9 zeros, and then 16384. Okay, but I'll multiply that by 5, and I've got this. And so this is going to equal 8.192 times 10 to the negative 10th. So that means decimal is moved 10 spots to the left. I tell my students, if the calculator puts it in scientific notation, then just answer in scientific notation. Okay, that's it for the section, and I'll see you next time.